Very good morning. So we are going to do a FIR filter design, okay, by using frequency sampling method. Okay, idea is you have a frequency response. Okay, suppose this is a low pass filter frequency response. So whenever you find out h of n filter coefficients, normally it will be of infinite duration. Okay, in the earlier method of windowing, what we did is that, so once you have got h of n was infinite duration sequence, so you multiplied this with a window function, so to cut off the additional part, so that you made it as a finite sequence, right? Now in this case, you take the original frequency response and you sample it. This is your frequency response. You collect samples from it at equidistant points. You take 4 samples, say, for example. Okay, now since you have taken 4 samples, the output is going to be a finite output only at these samples. Okay, so this is how you are converting your infinite impulse into a finite impulse. Okay, so that's how you design your FIR filter. Okay, you collect samples at equidistant points, and using these samples you find out your filter coefficients. This is essentially the concept of FIR filter design using frequency sampling method. Okay, now to achieve this you need 2 parameters. One is theta of k and h of n. Okay, so first I'll share you the formulas for theta of k and h of n. Okay, so theta of k is given as minus n minus 1 by n pi k, where k takes the values 0, 1, 2 up to n minus 1 by 2, and it is equal to n minus 1 into pi minus n minus 1 by n pi k, where k runs from n plus 1 by 2 up to n minus 1. Okay, this is the case when n is even. Okay, now what happens when n is odd? Exactly the same formula, but just check when n is, say, odd value, say 3. So 3 minus 1, it becomes say n is sorry, the earlier case n is odd. I have written it wrong. So the earlier case n is odd. When n is even, this formula is getting changed. When n is even, this is n by 2 minus 1, and this becomes n by 2 plus 1. That is the only change. Okay, then only it makes sense, right? So this formula is for n equal to odd, and this formula, the exact same formula, only you replace these two, you'll get for n equal to even. Similarly, the value of h of n is given as 1 by n h of 0 plus 2 times summation and k equal to 1 up to, I'll just put this in a different color because I'm going to change it, n minus 1 by 2. Okay, a real part of h of k e power j 2 pi n k by n. Okay, so this is a formula. So this is a formula when n is odd. When n is odd, the formula term which I have indicated is n minus 1 by 2. When n is even, this formula becomes n by 2 minus 1. That is the only change. Otherwise the same formula will be used. Okay, so this is how, these are the design formulas. We'll be using it for designing our FIR filter by frequency sampling method.